So this is just a snapshot of an alternate way to find your line of best fit and your equation of your line in case you're having trouble with the Desmos one. My numbers here are completely made up. So make sure that you're putting in your forces and your accelerations that you found in the lab. And then you are going to highlight the whole area, including the headers. So make sure you have the headers in there when you are doing it, because that's going to help you put it on the right axis. If you do not know how to highlight in Google Sheets, then click away from where you want to go. Hover over where it says force. You're going to push the button down and keep it down. Don't release it. Then drag over here until everything is highlighted. And if you're doing this in Excel, that would also be the methodology. Over here, right above the J is when you mouse over it, it'll say insert chart. It looks like a little bargram. You can also find it from the insert menu. It sometimes takes a little bit for it to come up because it's processing and creating their items that way. Okay. If your force came in on your x-axis, then you are good. Sometimes it gets confused, especially if you highlight the opposite direction. Okay, so you might have to go and drag and drop it the other way, but your force, that is what you're changing, the force applied. Okay, so that is your independent variable, and then your acceleration is your dependent variable. How can you remember the difference between independent and dependent on where they go on the graph? There is a nice little acronym. Dry mix. Dependent is on the y-axis. Okay. Manipulated, that's the one that you as the experimenter manipulate, is the independent, and it's on the x. So if you remember dry mix, that's going to help you remember which one. And the R is, I think it's response, it's something like that, because whatever the force is, that's what's creating that acceleration. And how do we know this? Force equals mass times acceleration. Mass is going to be basically your constant in this area, because your structure is you're using the same object and you're just trying to see the relationship between mass and acceleration. Could you look at this diagram and kind of get an estimate? Yep, if force increases and we're keeping the same mass, then acceleration has to increase. So they are directly proportional. Okay. So mine came in the correct way. So I can then continue on. This right now is a plotted line. So for everything, it took the force of 10 and the acceleration of y. And so then it did 10 on the x, 1 on the y, and it plotted a point and so on. So it plotted a point at each one of these items. But that is not actually what we use in science. What we want in science is something that is a true mathematical representation. Let me try to draw a line there. Maybe we'll see it a little bit better. So we're going to be looking for a line that looks more like this, because we know we have a little bit of errors in our measurements. Something could happen where we have a little bobble, and that is okay. That happens in real life, that these things happen where we deviate from the line of best fit. And that's what we talk about when we justify, when we write our paper up. But if yours fit the line perfectly, sometimes we think that might mean the data is too good. Okay, so you never change your data. You take whatever data is there, because if you change your data, that is lying. And then you write up the line of best fit to see if you can see directly proportional or what proportionality it has. And then you test your data to see if it is a good data set. Okay. Have use row 1 as headers there so that the force and the acceleration come right in. You don't have to do anything fancy now. In real life, you would also have your units and everything else there, but I'm not going to have you do that extensive. We're going to go down and we are going to change to a scatter one. The scatter one's still going to plot all those same points. They are just putting it at the particular items so that you can actually draw a line of best fits. If you were doing this by hand, which we never do anymore, you would just get a ruler and do exactly what I did at the start. But that's not what we do anymore. If you had to change the title, this is where you would go. If you wanted to change the colors of anything, here is where you would go under series. Okay. Now down here, you see trend line. That is just the line to best fit. So you're going to click that on. Okay, if you want, you can turn on data labels. That's just telling you what actually it was so that you can see kind of your deviation. Sometimes that gets a little busy. Error bars are just showing you between standard deviation. So most of your data should be fitting within one set of error bars, or you might have too much error in your thing. So having these on is just a really nice way so somebody doesn't have to calculate the standard deviation and figure it out. So all my data fit within the error bars. So I can be pretty happy about that. My trend line is my line of best fit. And I'm going to do my label here and just say use the equation. And here it is. It's equal to blank X plus something else. Does that look familiar? Yep, because it's a line of best fit. So what do we expect it to be? Y equals mx plus b. What is your y? Your y is your acceleration. Your m is going to be your slope. So in this case, we have a slope of 0.1. And then our x is going to be our force. So the slope times the force plus the y-intercept. Now, sometimes we're given a y-intercept. In this case, I have an actual value. And other times my data might start here, and then the line of best fit would be extrapolated to go over and give us our line of best fit. And extrapolated just means we want the extra length. So we want the extra length, and we extended our line of best fit. So there's some math terms in there. You're not necessarily going to see those in the test, but they do come up on the AP test that you have to understand the difference between interpolated, getting a data point inside, and extrapolated, getting a point on the outside. Make sure your trend line is in there. If you want to put on your R-squared, you're welcome to. That is showing how accurate your line is. Okay, so we have an accuracy of 0.996, which is because I made up these numbers. And so the higher R-squared that you have, you want to get it as close to 1. In real life, when you're doing like a biology experiment, you're going to often see them at like more like 0.95. And if you're ignoring friction, you're not going to get to 100%. So there's lots of things that go in and out when you're doing these items. So that's just a quick little check. If you could not get Desmos to work, you can also sign up for a tutoring appointment if you could not get either of these to show the line of best fit and your equation. Have a good day.